What's going on, guys? Welcome to this video. In our last lecture, we listed our choice, our voltage choice of our current choice, duty cycle, and also the switching frequency. So in this video, we're going to start our pre-design calculation. This is where the calculation will begin. So our output power is P naught, which is P output equals to V output times I output. So we multiply our required output voltage by our required output current. We get 36 watts. And then coming to our input power, we have power over efficiency. So this is the amount of power the circuit draws. So 36 watts over 0.95. This is our efficiency. So which gives 37.9 watts. So it's almost close. It's almost close to the output power. So our low voltage, for low voltage now, we have 85 root 2. 85 times root 2, we have 120 volts. And we have for high voltage, we have 265 times root 2. We are having 365 volts. What this means is that this is the peak voltage. So if anything happens and the voltage eventually goes high, which is root 2, this is what we should get for the low side, right? So if we are getting maximum of this one, of the low side, it should be this. And if we are getting the maximum of the high voltage side, which is root 2, it should be this. So the RMS initially is 85 volts for the low, but then the peak voltage now, if in case the amplitude fluctuates, we have 120 for the low voltage. Now for the high voltage, in case the amplitude fluctuates too, we are having 375 volts. Now let's come for our AC line, our AC currents. So our AC current is calculated as P input over V low. So this L you see here is the low value of the current, the low value of the AC current. So our P in is 37.9 over 120, and so we get 0.32 amp. And then for our AC now, the AC current of the high voltage now will be P in over VH over V high voltage. We are having 37.9 over 375. So we are getting 0.1 amp. So the maximum current we are getting here for the low side is 0.32, and then this one we are having 0.1 amp. So this is just the basics. This is just the basics. We still have more to cover. So this is just our output power, and it doesn't draw much power. And then for this one we have 37.9 watts. It also doesn't draw much. So like I said, the low voltage basically is when the amplitude begins to fluctuate, when it gives high voltage for the low part, it should be this 120 volt, and then for the high part it should be 375, right? So with that said, I'll see you guys in the next video.